So now our topic of discussion is going to be diffraction of light. So till now, what were the concepts that we have seen in wave optics? We saw what is Huygens principle. Then we saw what is superposition of waves. Then we saw what is interference and what are the condition for constructive and destructive interference in terms of phase difference and path difference. We saw both. And the last topic that we saw was YDAC, which is Young's double slit experiment, right? So the last topic that is left out in this chapter is diffraction of light. Actually, there is another topic which is polarization of light, but that part is removed from your syllabus for this year. So since it's an independent topic, I'm leaving it. So now we are going to discuss about diffraction of light. Okay. So what is diffraction? That is the first question we need to answer. So on the first day when I gave introduction, if you remember, I would have explained this term diffraction. Not with respect to light, but with respect to sound, I would have explained. Right? Do you guys remember that? So, listen. If we have a screen here, okay? If we have a screen here, so in Young's double slit experiment, there are two openings, two slits that are there. So instead of having two slits, if I have only one slit S, okay, if I have only one slit S, then if light is made to pass through the slit, okay, see the slit is drawn on bigger only for understanding purpose, okay, concentrate. Now, what do you think will happen? This light, okay, let's say we have a set of parallel rays that are entering through this opening. What do you think will get captured on the screen? What would have been our expectation? That we would have found a bright spot at this place. Right? That is when light is passing like this, we would have thought that only this part of the screen will have the light falling on it. But what do you think will happen in reality?
It will get spread.
It will actually get spread. Means it will start bending like this. So the light, when it is hitting the obstacle, it is not only the portion where the light is traveling parallel to it will have the bright spot, but due to the phenomenon where the light is getting bent when it hits the obstacle, you can observe some bright spot at these two places. These two places are technically called as geometrical shadows. Okay. So the phenomenon, okay, diffraction is also a phenomenon. Phenomenon means something which we can see. So how do we define it? So write down the definition. The phenomenon of what is happening to the light? It is getting bent.
Bending.
The phenomenon of bending of light under what scenario? See, bending of light doesn't mean refraction always. Refraction. We have studied refraction also as a phenomenon where the light gets bent. But what is the difference between that scenario and this one?
Change in medium.
There in refraction you have different media present, whereas here you don't have any medium that is present. It will happen because it is encountering an obstacle. Okay, the phenomenon of bending of light, when light hits an obstacle, is called diffraction. Okay, this is the simplest and the easiest definition that is possible. Okay, I hope this is clear.
Yes.
Now the important point to be discussed about this is, see, if this was a concept That is very easy. If it is only definition, we could have learned after Huygens principle itself, right? But we are learning this after interference because there is a specific reason for it. I will tell you what it is. Concentrate, okay? So there's a tricky topic. I suggest everyone to concentrate. If there is any doubt, get it clarified. Okay. Now, before I proceed, I just want to recollect these terms. So, what is the condition for constructive interference? In terms of phase difference, in terms of path difference. So in terms of phase difference, what is the condition for constructive interference? It is even multiples of pi where n belongs to z. And what about path difference? Path difference is n times lambda where n belongs to z. Right? Similarly, what is the condition for destructive interference? It is 2n plus 1 into pi or 2n minus 1 into pi. And what about the path difference? Right? We have already seen all these things. Right? Now, having these points in mind, I'll tell you why I'm talking about interference in the case of a single opening. Okay. If you observe, you have only one slit. So for you to observe interference, that is for you to see the pattern of bright spot and dark spot, till now, how many openings did we see? The light needs to pass through how many openings?
Two.
We need two openings, right? For interference to take place, we need two openings where on the screen you will have bright spot, dark, bright, dark. It will be a pattern like that, right? But this diffraction of light is going to tell you an important fact that if the opening through which light is passing has an aperture comparable to the wavelength of light passed through it, we can observe an interference like pattern. Okay, so here the important points to be noted is if the opening, that is the slit size, is having an aperture comparable to the wavelength of light. So wavelength of light will be very, very less, right? If you are able to make an opening which is almost comparable to the wavelength of the light that you're trying to focus on the screen, then you can observe an interference like pattern. I will show you a small activity for the same. If you have noted down, let me know. If you have finished noting it down, let me know. You're done?
1 minute. Done, sir.
So here an outline that I'm going to explain is, if you take a blade, Okay, you take a blade and you try to keep them as close as possible so that you allow only little bit of light to pass through them. Okay, this is the opening I'm trying to talk about. Means these two blades are going to be kept very close to each other. Okay, and light will be passed from one side. On the other side, there will be a screen, and on the screen, observe what kind of a pattern you are going to find. Okay, so listen.
Today, demonstrate diffraction at a
Are
single
you able to
slit.
hear this voice?
All of you know what is diffraction.
Yes, sir.
Yes, sir.
Yes, sir.
Diffraction means bending of light rays around an obstacle and spreading light waves into the geometrical shadow. And a laser light.
See,
You can
I'll tell you what all he is going to. He has a laser light, which
use
is of green color, right? And he has a box. So in that box, the cap is there, right? There will be an opening. See what he's going to do.
green or red laser light. And first of all, we have to make a slit for the experiment. That is the main part of the experiment. To make the slit, remove the lid. And on this lid, you cut.
You're able to see that opening? The
Yes, sir.
opening is there
Yes,
such
sir.
that back side there are two blades that are kept.
A small slit, a small aperture by using a sharp aperture by using a blade. And opposite to that, fix two blades like this. Okay? Parallel to the slit. Fix one blade here, you can fix the blade gap between
You're able
the
to see
edge of,
passing light.
leaving
Look
a
at the
small
light
gap
passing.
in between the sharp edge of the blade over here. So that through the sharp edge of the blades,
You're able to see the light?
gap between the edge of the blades,
Yes,
we
sir.
can pass light. You can see the light going up and down. That is a small gap between the two sharp edges of the blades. Very, very small gap. You need a gap of a hair length. A small head, we can make a hole like this, so that through this we can insert the LED. Okay, this way.
Okay. Now tell me one thing, guys. He has kept it like this, right? So he has passed
And
it.
the back side, we can make a hole like this, so that through this we can insert the LED. Okay, this way.
So now he has switched on the light, right? If this is focused on the screen, okay, the whiteboard is there at the back. No? That is what he is going to use. If this light is focused on the screen, what do you think will happen? What do you think you can find?
The light will
That
spread.
is like so. The light is there. No, the green color light is coming out, and here is the box. If this is focused on a screen, what do you think you can find on the screen? So since it's a green light, I'll give you wait. I'll use green color. You will find one spot like this, or will you find a spot like this?
First
So
one.
first or second?
Second one.
Second,
Second one.
Second. Huh? Why do you think it is second?
Bending of light takes place.
Yes, but second is wrong. It is first. What did I say? Bending of light will be clearly visible under what scenario?
Small opening.
You need to have a small opening. Look at the size of the opening that he has. It is very big, right? So you're going to find only one spot. It is because here the cap is open. But we have to remember one point. What is there at the back of the cap? There are two blades. And what is the reason for using two blades? Because we are trying to create a sharp edge. Okay. So, and you have created a very, very, very small opening where the size of the opening is comparable to the wavelength of the light. When that is going to happen, you yourself see what is going to fall on the screen.
And the front side we can cover with the lid. On the lid we have the slit made by using two sharp edges of the blades. Fix it like this. And for keeping the laser horizontal, we can use some support here. Keep it horizontal. Switch on the laser. When the light is allowed to fall on the screen over here, we can see on the screen. Normally we expect what? When light is passed through this slit, we'll be expecting on the screen a thin, narrow image, illuminated image of this opening. But what will...
So now comes the next question. Now you have an opening, right? Like the green light is kept in this way. Now it is covered with a box where there is a slit that is made. So what do you think will happen on the screen? Will you find this? So what do you think will happen? You're able to understand. So when it is closed, when the cap is closed, what is expected?
Diffraction.
Diffraction means what should happen? You will find a green spot. Am I right?
Yes, sir.
Yes, sir.
So what I've drawn is right, no? Yes or no?
Yes, sir.
Because according to what we discussed, the light should bend and it should fall on the screen, right?
Yes, sir.
Correct? No? But see what is going to happen.
We'll be seeing at the center a wide and bright image due to the diffraction. When the light waves bend around this circle, I will show you the slit. I will show you that after switching off the light.
But what is happening?
Okay.
So what we expected. What is that we expected? We expected only the central spot,
Sir.
right? But what is it you're able to find on the screen? You're able to see the output of what pattern? Output of interference, right? So whatever we guessed was also wrong. Right? This is not going to happen. So what is it you're going to find? You will find an alternate. You will find an alternate what? Bright and dark fringes in such a way. Wait, I'll crop this image. It's gone. Okay, you'll find a set of bright and dark fringes such a way that, observe guys, the central spot is there, right? The central spot is what is, I'm not sure why it is not right. Wait. The central spot is called as the central bright fringe. I hope now you are able to understand how exactly interference pattern looks like. Right?
Yes, sir.
Yes, sir.
So, in between, you are able to see the dark spot, this dark spot. Similarly, you will have a bright spot. Okay. So, this pattern that is observed on the screen, under what scenario, guys? Very, very important condition to be kept in mind. It will not be applicable whenever light is passing through an opening. but it is applicable only when the light is passing through an opening which satisfies what condition?
Wavelength.
Yes. The wavelength of the size of the opening should be comparable to the wavelength. Only then you can observe this kind of a clear pattern. Okay. But you can ask me a question, is this not interference? Yes, it is interference. But generally, what did I say? For interference to take place, how many light sources are needed? You need two openings, right? But here it is happening through one opening itself. That is why we can call this as self-interference itself. Generally, this word is not used in any of the textbooks, okay? But we can also call diffraction as what? Self-interference, provided the opening is very small. I hope you're able to understand this. So I told you there is a tricky part, right? In this, the trickiest part is giving an explanation for why this is happening. Okay. So when we derived the conditions for Young's double slit experiment, we had two sources. If you remember the derivation, we had two sources, S1 and S2, and a point P was taken where we calculated S2P minus S1P, which came out to be y into small d divided by capital T, all those things. You remember? So where this S2P minus S1P was called as the path difference. Then we use a condition for what will happen if the path difference is n lambda, what will happen if the path difference is 2n plus 1 into lambda by 2. Because that is a condition, mathematical condition for constructive and destructive interference. But here, what is the disadvantage? Here I am able to define path difference because I have two different rays that are going. I am able to see those two rays going from two different openings. Whereas what is going to happen here?
There is only one light source.
There is only one opening, right? So carefully observe the explanation that I am going to give. Okay. Please observe it carefully. So I'm repeating it. The central spot is called as the central bright fringe. Okay. All other bright fringes have another name, which I will tell during the process of explanation. Similarly, the dark spots have other names also. Okay. So concentrate. Now I'm going to give you an explanation. All these explanations are done by us. Concentrate. Okay.